Okay, so now we're gonna work on trying to factor trinomials where the leading coefficient or the coefficient of the squared term is a prime number and it's not a 1. So this makes the process a little bit more complicated, but the process itself stays similar. So I'm looking, and because this number is not a 1, I can't just put x and x at the front of my binomials. However, it is a prime number because the only numbers that multiply together to make 3 are 1 times 3. So what that means is I can have a 3x and a 1x in my binomials when I start to make. Because 3x times x makes x squared. Now, I need to start the process just like we do if the coefficient was a 1. I want to find the set of all numbers or all factors that multiply together to be positive 6. So, and because I have a plus sign in the middle as well, there's no negatives anywhere. I only need to use positive factors. So my factors of 6 are 1 and 6, 2 and 3. Now, the coefficient of the x squared is a 3, which means that I can't just sit there and say, oh, which pair of numbers add up to make 11, because it's not going to work out for me. Because when I go through the process of distributing, one of those numbers is going to be multiplied by this 3 right here. And the other one is going to get multiplied by a 1. So I need to go through and I need to figure out, well, which one of those numbers in the factors it needs to be multiplied by 3, so that way when I add the numbers together, it will make 11. Well, so I'm going to come up here and say, all right, well, one option is I would multiply the 3 to the 1. And let's see what happens when I do 3 times 1 plus 6. I want to see if that equals 11. Well, 3 times 1 plus 6 gives me 9. Well, that didn't work out. Well, before I go in and I go to the 2 and the 3, we have another option, which would be instead of multiplying the 1 by 3, we could multiply the 6 by 3. And I want to know, what does that add up to be? Well, 1 plus 6 times 3. You do 6 times 3 first, that gives me 18. Add 1 to that, that gives me 19. Yep, so neither one of those options work. So I know that my factors of 1 and 6 do not work when I'm multiplying this thing out. So now let's go to the 2 and the 3. Well, one of those numbers has to get multiplied by the 3. And if you don't understand why, you'll see why in a minute when I go through and I redistribute out this the product of the two binomials. So I'm going to say, let's see if the 2 gets multiplied by the 3, and then if that adds together to give me what I want. Well, 3 times 2 is 6. 6 plus 3 make 9. Well, that didn't work. So we have one other option. We could have positive 2 and positive 3, but this time I multiplied a 3 by 3. The 3 that was in front of the x. And I'll see what that adds up to be. So PEMDAS says, do your multiplication first. 3 times 3 makes 9. 9 plus 2 makes 11. So I have found what needs to happen. Now that I know I have to have a plus 2 and a plus 3 inside of my parentheses, I got to make sure I put them in the right spot. I need to ensure that the 3 that I'm putting inside of one of these binomials gets multiplied by the 3x. Well, I cannot put the plus 3 in here because the 3x will never multiply to that. It just doesn't. It has to multiply to what's in the other set of parentheses. So what I need to do is I need to make sure the plus 3 goes in the other binomial, which means that the plus 2 has to come here. Now, to see why this is the way it is. Now, this is my answer. I fully factored this problem. But if I start the process of distributing, so 3x times x makes 3x squared. Then I would have to take the 3x and multiply it to the plus 3. So 3x times 3, which gives me 9x, but I'm just not writing that at this moment. Then I would take the positive 2 times x, 2 times 1x gives me 2x, and then 2 times 3 gives me plus 6. Well, you look here, we have the 2 was multiplied to a 1x, and the 3x was multiplied to a 3. That's the same thing that's happening here. The green 3 is the 3 on the x, and the blue one's the one that went in the parentheses, and then this other 2 it wasn't multiplied by anything, which means it's multiplied by a 1. And if I combine these terms, I'd have 3x squared. 3 and 3 times 3 make 9, plus 2 make 11x, and then plus 6. So it multiplied out to be what I originally started with. So that was the answer. All right, let's go to number 2. So trying to factor it, and I look and I have a coefficient that is not 1, so I have to do that same process over again, where I have to account for all the factors of this term. Now 7 is prime again, so I have 1 and 7. So that's fortunate because I don't have a whole list of numbers to do trial and error to find the factors. So because of that, I know that I'm going to have a 1p in one of my factors, and I'm going to have a 7p in another. Doesn't matter which parentheses you put it in because, again, multiplication is commutative. Now, I want to find the numbers that multiply together to be 6. I'm not worried about the 1 and the 7 when I'm doing this. I'm just trying to figure out what times what makes positive 6. Well, I have plus signs everywhere, so I only have to worry about positive factors. So we have 1 and 6 and 2 and 3, just like before. Well, when I go through the process of distributing, like we saw in the previous example, one of those numbers is going to get multiplied by a 1, and another one of those numbers can get multiplied by the 7, because I really have a 1p right here when I do my distributing. So I'm going to test, I'm going to do trial and error and see what happens. So 1 times 1 and 6 times 7. And I'm going to add those together and see if I get this number right here in the middle. Well, 1 times 1 makes 1. 6 times 7 makes 42, which if I go through and I add those together, I get 43. That combination of numbers did not work. Well, I need to switch them around and see maybe I have the right set of numbers, but I just multiplied them by the wrong things. So let me write that 1 and a 6 again. And instead of multiplying the 1 by 1, let's say what happens if I multiply the 1 by 7 and the 6 by 1, and then add them together. Well, 7 times 1 is 7. 6 times 1 makes 6. 7 plus 6 makes 13. I don't even need to test the other pairs because I have it right here. So I need to make sure that the 7 is multiplying to a 1. The only way I can make sure the 7 is multiplying to a 1, now the green numbers are the p's. The purple numbers are going to be the numbers that go in the back side of the parentheses. So I need to make sure I have 7p times a 1. So I go find 7p, and I have to put plus 1 in the other binomial. That's the only way they'll multiply together, is to have 7 times 1 right there. And now I need to have the 1p multiplying to a positive 6. So I have to separate the 1p and the 6 from each other so that way I can ensure that they multiply together. Here is my factored form of that trinomial. And as you do more of these, they get better. All right, let's go to 3. So 3, I look and I say, all right, I don't have a leading coefficient of 1, so that means I have more work in store for me. So the only numbers that multiply together are 1 times 2. which is fortunate for me because that means that I know I'm going to have a 1n times a 2n to make 2n squared. Now I have to figure out how to make the 21 here on the end. Well, we have a negative 17 in the middle, so that means I have to include both positive and negative numbers for my factor list. So 1 and 21 make positive 21. So do negative 1 and negative 21. Then we have 3 times 7. And we have negative 3 times negative 7. So those are my factor lists. Now, I didn't leave myself enough room to do what I need to do, but I'll move the numbers as I need to. Now, through the process of foiling or distributing the numbers out, I need to create a negative 17 after I multiply one of those numbers by the 1 and one of those numbers by a 2. So it's a trial and error game. So I'm going to come here and say, all right, well, 1 times 1, and then I'm going to take the 21, I'm going to times it by 2. These green numbers are the end numbers. All right, and then I'm going to add them. So 1 times 1 plus 2 times 21 makes 43. Ooh, that wasn't even close. Okay, now I could also go through and say, well, wait a minute. I need to say, well, will it be any better if I multiplied the numbers in a different way? So 1 and 21. But instead of multiplying the 1 by 1, I'm going to multiply the 1 by 2, and I'm going to multiply the 21 by 1, and I'm going to re-add. So I do that, and I have 2 plus 21, which gives me 23. Well, that didn't make my negative 17, so I've eliminated 1 and 21 as possibilities. Now I go to the next set, and I say, okay, well, negative 1 and negative 21. I got to multiply one of them by 1 and one of them by 2 and add together. I'm going to kind of do both of these at the same time. I'm going to kind of switch them around so I can see which ones will add together. All right, so negative 1 and positive 1 make negative 1. Negative 21 and 2 make negative 42. Add them together, make negative 43. That's not it. All right. So now I go and say, well, what happens if I multiply the negative 1 by 2 and the negative 21 by 1? Negative 2 plus negative 21 give me negative 23. That wasn't it either. Say, okay, fine. Let's go to the next set, which would be 3 and 7. I'll move the negative 3, negative 7 down so that way I have some more room in case I need it. So one of those has to get multiplied by a 1, and one of those has to get multiplied by a 2. And then I'm going to try to add them together. Well, 1 times 3 is 3, 2 times 7 is 14, 14 plus 3 makes 17. Hey, I got a 17, but it needed to be negative. So how about instead of rearranging and multiplying the 3 times 7 and the 2 times 1, we go right to our negative numbers and say, wait a minute. We found the way to make 17, but the sign is wrong, so let's go to our negative pair. So 1 times negative 3 plus 2 times negative 7. 1 times negative 3 is negative 3. 2 times negative 7 makes negative 14. Negative 3 and negative 14 add together to be negative 17. So I have found the way to make negative 17 in the middle. Now, remember, again, the green numbers are the coefficients of n. My purple ones are the other numbers that go in the parentheses. I need to be able to multiply 2 to the negative 7, which means the negative 7 has to go in the other binomial. And I need to make sure that the 1 gets times to the negative 3, so that means the minus 3 goes in the binomial away from the 1 end. And there's my factored form. Now, again, we don't have to multiply, or excuse me, we don't have to write the 1 in front of the n, in front of our answer. I just write that so that way it'd be a little helpful here to start with. All right, and let's do one more example here. Where we have the same, actually, let's go where I have a plus and a minus here. Because isn't that what we just, yep. So that way I have opposite sides. All right, and I got to pick a problem that I like. Let's go number 6 right here. So we're going to do this one. So again, we're trying to factor. The coefficient in front of the p squared is not a 1. We're lucky that it's prime. So the only numbers that multiply together to make that 5 are 1 times 5. So I know that inside of my binomials that I'm making, I'm going to have a 1p and a 5p. Now, I got to write out my list of factors that make negative 30. Well, because I see a negative sign, I have to account for both positive and negative factors. So the numbers that make negative 30, 1 times negative 30, negative 1 and positive 30, 2 and negative 15, negative 2 and positive 15, 3 and negative 10, negative 3, negative 10. What is happening? And 5, negative 5, or positive 5 and negative 6, negative 5, positive 6, all multiply together to make that negative 30. Now, like the previous ones, one of these numbers is going to get multiplied by the 1 in front of the p, and the other one's going to get multiplied by the 5 in front of the p. And then I still need to see which ones will add together. These are p numbers, not n's, to make positive 19. So, and it's trial and error to start with. And as you get better at it, you don't have to make so many guesses. But 1 times 1, negative 30 times 5. And I'm going to go evaluate. 1 times 1 plus 5 times negative 30. Negative 149. Nowhere close. So, let's change around the factors and say, all right, well, maybe I had the right numbers, but I just times them wrong. So I'm going to times the 1 by 5, the negative 30 by 1, and I'm going to try again. Well, 5 times 1 is 5. 1 times negative 30 is negative 30. That makes negative 25. All right, so neither one of those pair numbers worked. So I have to go to the next set and say, all right, well, what if I made the 1 negative and the 30 positive? Multiply the negative 1 by 1 and the 5 times the 30 and add them together. 5 times 30 is 150 minus positive 149. Nope, nowhere close. And we go to the next set and say, all right, well, maybe you had the right pair of numbers, but we multiplied the wrong things. So I go multiply the negative 1 by 5 and the 30 by 1. and I re-add. Well, 1 times 30 is 30, and 5 times negative 1 is negative 5. You add them together, you get positive 25. So no, that didn't work. All right, well, it takes us to 2 and 15. All right, so let's start by multiplying the 2 by 1, 15 by 5, add them together, see what happens. Well, 2 times 1 is 2. 5 times negative 15 is negative 75. I add those together, I get negative 73. Nope, that's not it. Well, maybe I had the right numbers. I just multiplied the coefficients incorrectly. So I'll stick with negative 2 and negative 15. Multiply the 2 by 5 this time. Negative 15 by 1, and we'll add them together this time and see. 5 times 2 is 10. 1 times negative 15 is negative 15. I add those together, I get negative 5. Nope, that wasn't it. All right, well, let's see what happens if the 2 is negative and the 15 is positive this time. So multiply the negative 2 to the by 1 and the 15 by 5. We add together, we get positive 73. Nope, that didn't work. Well, let's see if we had the correct set of numbers, but we multiplied the coefficients to the wrong numbers. So negative 2 times 5, 15 times 1. I add them together. Negative 10 plus 15 gives me positive 5. Nope, that didn't work. And you'll notice a pattern here. Negative 49, positive 49. Negative 25, positive 25. Negative 73, positive 73. So I can save myself some time from testing down the road when I really start to get the hang of this. Let's go to the next set of numbers. 3 and negative 10. So if I multiply 3 by 1, negative 10 by 5, add them together, I would wind up with negative 50 plus 3, negative 47. Ooh, that's not it. Well, let's try to change the numbers around and see. Maybe we had the right numbers, like I keep saying, and we just multiplied the coefficients to the wrong things. So we multiply the 3 by 5 this time, the negative 10 by 1, and we'll add, multiply and add there. 15 and negative 10. Make positive 5. Huh. Well, they didn't work. So that takes us down to negative 3 and negative 10. Multiply the negative 3 by 5, the negative 10 by 1. Add them together. Well, wait a minute. Both of those can't be negative. It's supposed to be the negative 3 and positive 10. Took me till now to catch that mistake. I get negative 5. Nope, that doesn't work. Now, if I'm looking at the pattern that's going on, I could go ahead and predict that if I switched it around, negative 3 and positive 10, I switch what I'm multiplying. So the negative 3 gets times by 1, and the 10 gets multiplied by 5. It should be positive 47, because what's happening is I'm just changing the signs when I flip around what I'm multiplying by, and it does make that. So we're down to one last set of numbers, and you see how these things can be aggravating when you have a long list. Just wait until we don't have prime coefficients to start with, and they're composite numbers. All right, so I got to try 5 and negative 6. So let's try 5 times 1, negative 6 times 5. And we add together. Negative 30 plus 5, negative 25. Nope, not it. Let's change the order. So 5 and negative 6. Let's multiply the 5 by 5. The negative 6 by 1. Let's add them together, cross our fingers, and hope we found it. 5 times 5 is 25. 1 times negative 6 is negative 6. 25 plus negative 6 makes positive 19. I found it. So I figured out what times what makes negative 30, and when one of those numbers, or when those numbers get multiplied by the coefficients of the p's, it's going to make it so it adds together to be positive 19. Now, we're putting these numbers in. Remember, the green numbers are the coefficients of the p. The purple numbers are the constants that go on the backside of the binomial. So I need to make sure that 5, which is that green 5, which is really 5p, is multiplied to a plain old 5. So I have to separate the 5p from my plus 5. And I need the 1, the green 1, which represents the 1p, to be multiplying to a negative 6, which means I got to separate the 1p from the negative 6, so negative 6 goes in the other binomial. There's my factored form right there. So that's factoring.